For those of you. For those of you who are in the room, there is tea and some cookies in the back of the room, so help yourself either now or during the meeting or after the meeting. And if you're joining us here for the first time tonight, I'm going to be circulating a clipboard for the sign-in. Actually, I'd like everybody to sign in because this is how we keep track of who attends the meetings. So if you're not already on our newsletter list, and you would like to join the newsletter list, Rich does an excellent newsletter a couple times a month, particularly going into the legislative session with a lot of things that will be happening. Put your email address on there and indicate that, and we will add you to the newsletter. And if you are already, a member and on the newsletter list, you can just ignore that. The one thing on this sign-up sheet tonight that I am mentioning that I'd like people to think about helping with is we have a chapter banquet in the spring in April. That is a social event and a fundraiser for the chapter. Martha Mintak has carried the load on that for a number of years, along with Daryl Spencer, and both of them have stepped back. We need to put together a new committee this year to work on that, and we need to start soon so we can get a venue lined up. So if you would be interested in helping in any way, either setting up the logistics, planning, helping find a speaker, helping get donations for the event, please indicate that and be sure your email or phone number is on there, and we're going to start reaching out about that soon. So the other thing I want to make sure I mention before we get started tonight is that it's time to renew your membership for calendar year 2025. We are on a calendar year. And you can do that either online. You can pay Molly tonight, who has a Wear device on her phone, or snail mail still works. If you want to write a check and put it in the mail, go ahead and do that. What's important about renewing this month, if that's possible for you, is that at the end of December, the national office does a head count on our membership. And so that determines how many delegates we get for the convention when it comes up next summer, where a lot of policy decisions are made for the national level. So if you're able to do it by the end of December, I think it'll also determine how many delegates we get for the Minnesota Division annual meeting that happens in January. So please do it this month if you can. I just did mine this week.
There's a few membership cards back there to be mailed. If you sent the membership in recently, you pick it up and it helps if you mail the cards out to you.
Yeah, they're in the back room.
Yeah.
All right, and I know I announced at the last meeting we were going to have a conservation committee meeting as soon as I got a date. We haven't had that yet. We've been doing other things, but we will set up a conservation committee meeting and we'll still send that note out. So tonight, our December meeting, if you've been a member, in December, we usually like to do something a little more lighthearted, not so policy or oriented. And tonight we have a great presentation from Bob King on understanding, forecasting, and photographing the Northern Lights. So Bob King is known to many of us as Astro Bob. You may know him online as well as if you're in the rooms. He's an astronomer, a photographer, educator, and also an author. He has a new book about the Northern Lights, and he keeps all of us informed about what's happening in the night sky and when to go out and look and how to dress for it and all of that. So we've all had great opportunities to see the Northern Lights this year, and hopefully we're going to have more coming up. I know Bob's going to talk about that. So Bob's here to share some of his work, some beautiful photographs, and talk to us about what's ahead. And before I turn it over to him, or just a reminder for those of you, if you are online, please be sure you are muted. If you have questions for Bob, you can type them into the chat. And we'll ask them at the end of the presentation. And as I mentioned, we are recording if you came in late. So thank you. And bye.
Thank you very much, Julie. I appreciate that. Hello, everybody. Good evening. Fantastic. Wow, we've got like 24 people who decided, yeah, it's 10 below. How does that feel like again? Let's get in the car. Man, it's so cold just walking here. You forget, when the wind's on you, how little time you can actually survive. So we all made it in. You guys came here this evening. I was here 2 days ago, just to be safe. I came when it was had that nice warm snowfall. Again, thanks for the very nice introduction. I'm Bob King and I live up in Lakewood Township and I do look at the aurora quite a lot and I do a lot of posting on Astro Bob. I try to catch when we have a good forecast and post that and say, hey, tonight looks like the night. Maybe some of you have read those and said, I'm going out, and then discovered there was no northern lights at all. And so now when I do a forecast, I say, or nothing at all, mayhem. It could be the greatest storm of your life or nothing at all. And then sometimes when it's a minor aurora storm, it can become a major storm and you put in the time and we're delighted and really treated to a special show. This was one of the best northern lights, I think the best in our area this year. The one on May 9th and the following night on May 10th. Who got to see that one? Just a show of hands. So just a few of you. Then we also have had lots of aurora since, but this was taken that night, actually the morning of May 10th. And this couple have arrived at 1:30 in the morning after almost everybody had left. And they said, I was there, one of the last people there. They said, well, is it all over? I go, no. I said, take a look. It's just really starting. And the whole sky really began to erupt at about 1:30 in the morning that night. And so they got a great view. They stayed all night, as did I, because once we were together, we were like talking. So we stayed till twilight. We watched the aurora all night. Let's see what we have. It's giving us.
Hold it. Can we try this again? And I'll try it again.
There we go.
You want mine at work?
And there were just so many of them, and you probably have seen these like being underneath a Titanic mushroom,
Yeah.
where you see this enormous corona structure. It's called a corona aurora because it resembles a crown. Corona. And when the aurora really kicks in and we get the big storms, then you'll get a corona in the nighttime sky. And they often, you've seen these twist sometimes, and then fingers of rays become really bright until you want to shout. Sometimes, who shouted out loud? Just going, ah! It's almost like, and of course, a few of us have left now and again too, the northern lights. The very next night, we had some clouds in the north. Didn't look like it was going to be as big a storm, but this is the brightest aurora I've seen since I think 1989. These rays were shimmering in the sky. They weren't just, pictures do show beauty of the northern lights, but when you're there, you get to see the movement. And these were just doing this, just shimmering, and they were so bright that they illuminated, I didn't fake this, they illuminated the landscape. I could see all the trees. So I think this night, the lights were as bright as the full moon or close. So that's how bright the northern lights can be. And we're in a region where they happen fairly regularly. So we have the opportunity. As we learned, it's also a great time to do them because where the sun is in its cycle. Look at this corona aurora. By the way, the coronas, for those who have seen really big displays, they are so enormous that if you're photographing them, you can do pictures, as I'll show you with your iPhones and Androids. But when they get so big, I have to put on a fisheye lens in order to include or to get the impression that I saw with my eyes. And so some of these are very wide. Here's a horizon on one side, and here's the horizon on the next. That was taken with a 10mm fisheye lens, which I recommend for all hardcore aurora photographers because it's going to get this big and you cannot squeeze it into a normal camera. I've lost my clip here. Molly to the rescue.
Yeah, I don't know why.
She's great. And this was back in October. And then we had like almost a whole month of clouds. You know, there was one night where we had northern lights, and then it's been very cloudy.
Oh.
These were very intense red rays. This was the evening before, October 6th. And just a brief phase of the northern lights where they lit up red. And these were actually bright enough to see red. One of the reasons we don't see much red in the northern lights, even though our cameras will show it, is because our eyes are not as sensitive to red light. They are to green. And I bet you've all seen kind of that green glow, that limey color. That is the key color the eye responds to. So if you kind of faint, you can still say, yeah, it's green. The red has to be intense. And when it reaches a certain level, like, did you have a red sweater on, man? When it's first that sweater level, then we can see the intensity. Can you wave? Nice. Perfect demonstration of northern lights. But it really, and that usually happens during powerful storms where you have a lot of incoming material from the sun. Speaking of which, here it is. As Pumba said in The Lion King, it is a ball of burning, he didn't use hydrogen, gas. An enormous ball of hydrogen gas, not quite 1 million miles across. And it's located a safe distance, thankfully, 93 million miles away. Seems like it should get a little closer. We'd like to bring it in closer in the wintertime. So the sun has a cycle in terms of how much activity it shows us. And we measure activity. You can see it with an ordinary telescope and a filter. We see these dark splotches on the sun. And sometimes it's blank, and sometimes we see a lot of them. These places on the sun is where there's a lot of energy concentrated on the sun's surface. Magnetic energy, like you would find. I brought a pair of bar magnets. Of course, I figured this I had to get one day if I'm ever talking about the northern lights. And it goes up and down. So it peaks, lots of spots, you get up here, and then it drops down. Peaks, drops. And it does this regularly. Right now, we are at solar maximum. We are right near the peak. You can see minimum. You can get auroras during minimum from other effects. But when you have these sunspot groups, which are areas on the sun where there's a lot of magnetic energy concentrated on the sun, that sets the stage for big explosions called solar flares, which ultimately do produce the auroras. There are other ways too, but solar flares are a good one. Solar maximum is right now. So we see sunspots every day. Looked at the sun today and I saw some nice little sunspot groups. There's been some activity. I checked the latest forecast and there is no big time aurora yet in the forecast. It changes so frequently. So it's always good to check all the time. So I'm going to show you an app that you can get for your phone. Here it is. When you look at the sun, you see them in pairs. And they actually are like a magnet with its north and south pole poking above the surface, only millions of times stronger than a regular magnet. So there's a ton of energy in there. Don't you love this illustration? It's so simple and yet quite profound. This is ultimately what drives flares and the northern lights, the attraction of North Pole to South Pole on two magnets. Justify the $16 I spent here. There you go. Do connect just like that. North and South poles. Here's a more powerful magnet. And so we put an apple. Wow. So when you have a more powerful magnet, there's a lot more energy involved, isn't there? So you can launch, I don't think this person actually thought they were going to launch it. But it slipped from the grasp of the magnets. Here's a solar flare. You saw that there were north and south poles like a magnet. In very complex sunspot groups, there's lots of north and south poles very close, clustered together, and they can actually touch. And when they do, they produce this brilliant storm on the sun's surface. You can get a telescope and see that. Many times larger than the Earth sometimes. And you can see it happen in real eye. I have watched solar flares just evolve right in front of my eye through the telescope. It's something so enormous. And how big is it? How powerful? I looked it up. Typical flare, millions of 100 megaton thermonuclear bombs. Once again, isn't it nice that we're 93 million miles away from us? We got this vacuum of space separating us from these. But as we'll learn, this stuff does find a way to the Earth sometimes. When you do have an explosion from a flare, occasionally the flare will launch some of the sun's material, those superheated gases. The sun is so strange. It's not like normal material things. Hold on to this chair. It's neutral, right? It doesn't have an electrical current or anything. The sun's made of charged particles. It's so hot. There aren't just atoms as we know it that make things solid. It's a flow of electrons and protons. It's hydrogen gas broken down into its simplest components. So when the sun launches, when a flare launches, I should say, one of these massive, what we call coronal mass ejections. Who's heard of CMEs? Is that a familiar term for some? If you follow the aurora, it comes up very often because in the wake of one of these ejections of material from a flare, that starts rumbling towards the sun. And you'll hear, oh, there's a big coronal mass ejection. Did you hear about the coronal? No, I didn't. Well, now you know. But one that happened in May wasn't just a single CME, but we had a sunspot group or two that were just launching. It was almost like one salvo after another. And they stacked up and created sort of this, they started cannibalizing one another and became even larger. They struck the Earth, and the aurora was not just here in Duluth in a spectacular fashion, but as far south as the tropics. People saw it in like New Caledonia, somewhere in Polynesia. Not high up like we do, but it really spreads. It's visible. Look at the speed. These things can move up to 7 million miles an hour. That means if you launched one towards the moon, you'd get there in 2.5 minutes. Just to give you a sense of how fast that material can get to us. Normally, it takes about 2 days for solar material to arrive, but it can arrive within 24 hours. So you get a flare, and then you anticipate, we could get something. But of course, the flare has to be sort of directed towards us. You know, if it's off to the edge of the sun, it will miss us. So it helps if it happens near the center of the sun. Okay, now I want you to picture that cloud that you just saw heading towards the Earth, right, from an edge, and just hold that image in your head. We are not defenseless. We come back to magnets once again. The Earth behaves like a magnet. We use compasses, right? The compass points north because the Earth behaves as if it had a bar magnet running up and down through its core, with a North Pole and a South Pole. And that's from all of the molten iron that's beneath us, that's spinning and bubbling around, making currents and creating this magnetic field. And this magnetic cocoon protects us from a lot of what the sun delivers. This is a simple view of it. Makes it look like it's just a tiny sphere, but I want to show you how beautiful and lively this magnetic bubble truly is, because it interacts with the sun all the time. The sun pushes on that circle, that sphere, and turns it into a very beautiful thing. This is a visualization. There's the Earth. You see those lines around there? Pretty visible. Those represent, just like you saw before, magnetic field. Now we're going to see the sun's over here. It's blasting material all the time. The sun is so doggone hot, it is continually streaming stuff at us. And as it strikes that magnetic bubble, which has a lovely term, magnetosphere, that's the whole thing. It's pretty neato, as we used to say way back then. So we have this magnetosphere. It's like this giant comet-shaped magnetic bubble that wraps around our planet and protects us from the worst onslaughts of the sun. If it wasn't for that bubble, for that magnetism, the sun's energy and particles would strip away our atmosphere. And there would soon be no life possible on the planet. We think this is exactly what happened on Mars, because it does not have a big protective bubble like we do. We're going to watch what happens, just so you can kind of visualize what happens when a flare launches material, a CMB, towards the Earth. You're going to see it strike our planet's magnetic field. That material is bundled with some of the sun's own magnetism. It will couple with the Earth's magnetic field, get blown behind the planet, reconnect or some on the backside, and then slingshot that material back towards the Earth's polar regions. Watch what happens. There's the impact. Here we are folding in, squeezing, squeezing, squeezing. The magnetic field of the Earth, north and south touch. Particles delivered. It's like UPS. You know, they come in and they drop that box. The truck pulls up. The truck pulled up here and the sun delivered. And it coupled with our magnetic field, and behind the planet where it's midnight, the dark side of the Earth, the midnight side, that's where it happens. Didn't happen, a little bit happens on the front side. There is some daytime aurora, but most of it happens on the back when it squeezes together and then slingshots the material back towards us. So that's why we see most of the best auroras at night, particularly later. So you saw that material now, all of those little particles delivered to the polar regions, but not the North and South Pole. Nope, these two little crowns called the auroral ovals. Here's a picture taken in ultraviolet light. It's the sunny side of the Earth. That's the mountain. You can see it's got a little beanie cap. It's got a southern oval, and those are always there. 24/7, every day. They're always glowing up there. And the Earth is spinning underneath the ovals. So they're there. When we spin under the right part of the oval, let's see, that's what we see the north. Here's some diagrams. And I give you a website later. I've got sort of a list of websites you can photograph, with your phone. But this is the oval, the northern hemisphere. And of course, there's the one over Antarctica. The oval in the northern hemisphere is centered over northern Canada on our side of the globe. It's not on the Russian or European side so much as it is on our side. That's why we see auroras more often in Duluth at our latitude than people do in England, even though they are further north than us. That's the normal oval. Nothing going on the sun in particular, but there are always particles streaming in, striking the atmosphere and making it glow. And that's what the oval is. Those high-speed particles, and we'll look at the colors in a moment, make the air glow 100 miles an hour.
I have no idea where that popped up.
So, let's do it. So this is normal, no solar storms. You can guess what's going to happen, right? When that material strikes the Earth and we reconnect. So, next side of the planet, you can imagine what's going to happen to that oval. Watch. Oh, sorry, I set you up, but I had another slide. I wanted to just look a little bit to show you where the oval is located. City-wise, you can get a sense of where it is normally. The US, Canada, you see Greenland, there's Iceland over there with the Reykjavik. So Churchill, Manitoba here. Duluth right there. We are not terribly far from the oval. But if you live in any of those cities or anywhere along or close to that oval, since it's always lit up, you will see the aurora any dark night of the year. When there's no, they have long twilights in the summer, sunset's pretty late, so not during clouds. But that's why there are tours that go up into the oval, because there are a number of cities like Tromsø over here in Norway. They do a lot of aurora tourism because that city sits right under the oval. So if you have clear skies and you're in Tromsø, chances are you're going to see some northern lights. And the same is true. I don't have the other oval, but there's the southern oval. But where is that? Antarctica. Well, there's not a lot of tourism there. On the peninsular part there is, but that starts to get outside the oval. And it's not centered on the North Pole, but it's centered on something called the North Geomagnetic Pole. We don't have to have the details, but that's where the magnetic force comes up out of the earth and goes back in off to the other side. And it's offset from where Santa Claus and the elves all live. Oh, by the way, they should see some pretty good northern lights up there too. So during a solar storm, and this is where I wanted to go a moment ago. During a solar storm, that little tiny oval becomes like a giant bagel. It really puffs out and expands. And in the northern hemisphere, it's only got one way to go. South. As it expands, it moves in our direction. That, when we hear about a storm, that's what you should kind of picture. You're like, oh, there's lots of energy and particles coming from the sun. It is pumping energy into that bagel. That bagel is getting big and puffy, and it is spreading downwards in that direction. At the same time in Antarctica too, same thing. And people at the southern tip of South America, Australia, they would anticipate seeing southern lights. Just so you can see this diagram, because we're going to look at a couple of them. This is the night side. That's where all the action happens. There's the day side. Not too much aurora on the day side. There's no reconnecting on the day side, very little. Mostly on the night. Here's a time lapse showing you the progress of the storm. You start with kind of a smaller oval, and you can tell when it starts getting red, things are really pumping up there, and you can see it expanding. Right. Remember, the Earth is turning here. It looks like the oval is, but the way they illustrate this is this is actually the Earth turning out of the oval. So here in Duluth, we're seeing a wonderful storm at this point. As Duluth moves towards daylight, people over here, where it's midnight, see the aurora. We are doing the turning. The oval, during the giant storm on May 9th, it got so big, it left Churchill and much of Canada behind. It actually, that is a satellite image of that oval. That's all northern lights. And by gosh, the oval was over Iowa. They were seeing incredible displays. Here in our region, we had auroras all night. The other thing that happened was that the oval got so expansive that the aurora, maybe some of you saw this, it moved into the southern sky. And there was no aurora for a time in the north. It was just, oh. I looked around and went, there's no aurora. It's in the south. That's a rare thing. You get some beautiful colors with the northern lights. Cameras show them best. Who knows why? Why does a camera do so much better than our eye? Who wants to volunteer? It just comes down to two words, doesn't it? Time exposure. Gathering of light. You know, it's a bucket. It's gathering light like rainwater, so that when you see the final result, you can really see the colors. So the colors are accurate. Granted, on Facebook, some people crank them way too high. So you have to be careful in the process. You still have run into that. But this is fairly close to what it looked like. Green, a little bit of blue. You see blue in there? And some pink. So each one of those colors goes back to a different atom in the atmosphere. And it's so fun what's going on. It is pretty tough. You have all of those particles coming in, either that were sitting there anyway in Earth's magnetic field, buzzing around doing nothing, or delivered fresh from the sun. And here they're coming in, accelerated as they move downward towards those ovals. They're accelerated to 44 million miles an hour. That's, in that case, something as tiny as an electron, which is when you plug in your toaster. It's electrons that move through the wires that ultimately heat and toast your bread or light your light bulbs. Those little electrons come spiraling in down the whirly field lines of the Earth, and they strike the atoms in the upper atmosphere. And the atom is like, whoa, I was just relaxing. It really was. It was just taking it easy. When an electron hits you at 44 million miles an hour and you're an atom, you wake up and you become more energized. But you prefer to go back to sleep to rest. So you release that energy. The impact happens. And when you release it, the atom releases it as light. Pink light, green light. So it translates, it turns the motion into a different form of energy, light. And these zillions, lost count, how many brilliance must have to create a single sheet of northern lights. But that's what's happening with the stuff microscopically, those little electrons, the atoms, the very air you breathe is being energized, releasing light. It's a beautiful process. Green and red are the most common colors, and they come from, this is almost poetic, Julie, it's from oxygen. You know, we associate oxygen with those colors anyway, with plants, blood, and here they are in the aurora, green and red. The green aurora, you see the bottom of the atmosphere here, there's an airplane. Well, you think when you're up in an airplane going to San Francisco, you're really high. But people with airplanes will say, you know, I looked out at the earth, it looks flat to me. Well, of course, you're too close. You gotta get up. We live on a pretty big planet. But if you keep going, 60 miles is the bottommost aurora. But the green auroras that we often see are about 75 miles high. It's basically at 75 miles, it's outer space. That is, there's almost no atmosphere. Very thin air. The red aurora happens below, at the space station there, higher, about twice as high as the green aurora. And what's so cool about this is you can actually see this during a good aurora storm with your eye. See if I can picture here to show you. You notice where the green is. This is physically happening. This is the lower part of the atmosphere. And here's the upper part. And it has to do with the thinness of the air, the fact that oxygen at very high altitudes has enough time to relax. It takes a super long time to relax up there and give off red light when it does. Whereas further down, there are more atoms and they give off green. So you can see the difference just with your eye, the difference in altitude. There's more colors. Here we have the lowest auroras. Who has seen when the aurora really gets going, this sort of purpley border? Have you seen that purpley border?
Just once.
Just once.
And I never camera.
Right. But you had your eyes and you've got your memory. That, I love that purple border because it's very brief. It sort of ripples around. You're like, whoa, it's purple. Looks like Concord grapes or something. Well, that's not from oxygen, it's from nitrogen. Because in the air right now that we're breathing, it's 21% oxygen and about 78%, or so, thereabouts, nitrogen. So the primary, and it's also glowing in other colors we can't see, but oxygen and nitrogen create green and red for oxygen. Nitrogen in the air produces blue and purple, and also red, but a type of red that's not visible to our eyes. Here's that. Now there's a great purple bottom. Isn't that incredible?
Yes.
This is in the book, and I remember it took me about 6 months to get this guy to finally respond and say, yes, you can use me. I just said, do you think it's gonna look really nice? Because it was just the best photo of the purple aurora that I had ever seen. This is from Duluth. There are some nights, but some nights you can record the blue nitrogen with your camera. It's a little trickier to see with the eye because your eye doesn't respond so well to blue and it tends to be faint, but man, the camera will. Where can you see the aurora? I think you already have a sense of where it would be visible, but I just want to show you how your location changes your perspective on the northern lights. Here's the oval. We got a medium storm happening. There's Duluth, the red dot. These X's represent locations. So here, way up north, You might think, well, the farther north they go, the more we're going to see, right? No, you can outrun the oval and be in a blank area where no matter, you can go 360 and see nothing. So going farther north isn't always the best thing. The best thing is to get closer to the oval, wherever that's to be. So no, because we're way up here in Astro Island, as you get down further into Canada, you would see the aurora there in that location more in the southern sky. You'd have a grand show. Obviously, in here, right within the oval, you're going to see the aurora all over the sky during the night, probably all night long aurora. So my Canadian friends, they're always seeing the northern lights. And occasionally, when the storms are good, that oval will expand south. So here in Duluth, we will see it fill the northern sky, this particular type of oval. Sometimes it's bigger yet, as you saw in that photograph. It completely covers the region. It covers the whole sky. Now, if you're down in Texas and Oklahoma on this night, you probably saw nothing, right? Because you're too far from the oval. Does this make sense? How our location can really affect how often and how intense the aurora can be. So we live in a good spot. It's not the wilds of central Canada, even though it feels like it. But it's close enough that the oval comes down for a visit once in a while. Now, you will see during big storms reports of pictures of deep red aurora taken in places like Texas and Florida even. And the reason why you will only see photographs of red aurora is because it's the highest aurora. So it's like being able to see a mountaintop. Like when you're driving, you see the mountaintop. It's way visible from distance. The aurora is so high that they may see it this night in Oklahoma, but they would only get it with a camera and a time exposure. Right. So if you ever see a lot of red aurora pictures in the southern states, that's the reason why. The oval expands farthest south around local midnight. This is what really ticks people off. I'll say, did you get to see the aurora last night? They say, well, you know, I went out, I heard it was coming, I went out at 9, stayed till 10. I didn't see anything. It's like, I know usually I just hang out. The aurora is like a lot of things in nature. You're there, and it may not be happening right now, but you sort of plug into the environment anyway and listen to the frogs. I went through all the frog seasons this year, watching the auroras from the very first spring peepers all the way to the, what are the knock ones? Not wood frogs, I'll think of it, the mink frog. And then it was finally silent, and then the first ice. So you're out in nature, which is key because you're also hearing and experiencing other things. So the aurora, it's always good to go on the adventure, I say, because you just don't know. You'll make friends that you won't even know what they look like, but you'll start to recognize them by their voices. And I did a book signing a couple of weeks ago, and 2 women came up, and I didn't recognize them at all, but I went, are you Amanda? Like, yeah. I was parked behind their car. They get there before me often, and they're out just snapping away. So, and then people stop, and they want to know what you're doing, and then there's always, the sheriff's deputy. The lights are always lit. But, so yes, that whole, it points straight down that long magnetosphere around midnight. So you get the full bombardment. That's why midnight is the hour, or 1 a.m. But not always. The aurora is like everything else in nature, exception. So that's what makes it so much fun, too. Frustrating and fun. Either side of midnight, but remember, when we're on daylight saving time, it's either side of 1 a.m. So you have to stay up even later with someone else. Often starts like this. We've seen this a lot. I'm sure you've seen the quiet arc. And then you're watching it, and as it energizes up, it develops these little rays. And there's actually an electric current happening up there, high above your head. And those rays are moving along with the electric current in the atmosphere. So they dance left to the west, they dance to the right. And when it becomes this active, let's say you're out and you see that arc, you're like, should I stay or not? If that arc intensifies, that's the direction that you want to be on. If it's getting brighter, if it doubles, stick around. But make sure that you're dressed warmly. Unlike me, I'm out there, I'm like, oh man, I really should have brought something warmer or a snack. And this is a couple of Septembers ago, those arcs developed, they started to develop rays, and the rays are getting pulled out like some giant taffy, and it's getting higher and higher, and there's that impending sense of, oh my God, you just sort of drop everything and let it take hold of you, the northern lights. And this is that stage, as it was really blossoming, those rays now were moving up out of the northern sky, which is to the
I have
right.
no idea why it's Keystone
Oh, and up towards the top of the sky.
possessed.
Wow. Oh my goodness.
And this is a beautiful, oh, this is the starbursty thing. I haven't seen anything quite like it since that April. This was in Two Harbors, just north of Two Harbors. And they, oh my God, they were just, the whole thing was sort of pivoting. You've seen this, right? You know how that, oh, when I get the chills just describing it again, just thinking about it. And so I was taking this, again, you see the corona. And what you're seeing here, this is so cool, you're seeing a perspective effect. See if I brought the right photo. Yes. Can you see you see what's actually happening? If you stand in the middle of a forest and look up, those trees are all parallel to each other, aren't they?
Yeah.
But if you look up, the way our vision is, the way we perceive depth, the trees appear to merge way up top. Those are parallel rays like this, or swirls. But they're straight up and down. But when they fill the sky and we look up, they appear to come together to form the corona. So now it's really it's beautiful rays, and they're dancing. Here's another one. Look at all the colors here. Who can name me what color's producing, or what atom's producing this one? Anybody? Just shout it out. Oxygen. How about oxygen? How about
Nitrogen.
Yep, nitrogen up there. And then, the colors can mix too. So you can get blue and red together, forming sort of purplish or magenta. They do mix, and so you will get a wild variety of colors sometimes. Who has stayed up late after the corona's done, the rays are done, and you're looking up at the sky and you're like, what am I seeing? Are you familiar with the pulsating aurora? Have you seen it? Yes. You've seen patches of light flashing, sometimes so fast is you think, am I on Earth, or is this some other planet that I'm on? And it really is spectacular. This is produced by a kind of a complex mechanism that involves the Van Allen radiation belts and waves that are created up there that then echo on down into the upper atmosphere to create these amazing, they're really tough to photograph. It's a poor job. See how grainy this picture is, because I was using a super short exposure to try to catch the patchiness of them. But this can last for an hour, 2 hours. But sometimes what happens is that you get a second auroral storm after the pulsations. If you stick around, you start to notice another bright arc forming in the north. You start to see the rays stretch up. Stick around because you're going to get another blast. Each blast like that during the night is called a substorm. The whole thing is a geomagnetic storm. It's a substorm. Look at these beauties. This lasts 2 minutes. And again, caused by another effect way out in the magnetosphere. Kind of like when you see water flow past the rock, it forms a vortex. These vortexes come right down to make the aurora. They're called beads. If you ever see these things, beautiful, and they're nicely spaced, really brilliant at the bottom. This is weird. I saw this and I said to myself, what is going on? And so I took a whole bunch of images, strung them together to make an animation. And to me, it was the snake eating a rat aurora. I guess it doesn't look like it's sort of developed. It's too big, it's distended. But it's another special type of aurora called the giant undulating.
Oh, my God.
This is quite rare. People I know in Finland and Norway have seen this more often. I saw it once. And it's called omega because of the shape, like the Greek letter omega. So look, you can look for these things and be aware, and I describe each one of these auroras. So I mentioned about the big storms. Overall, they're called geomagnetic storms. You probably have seen these or heard of them. They're on the TV news sometimes. They range from G1 through G5, minor to extreme. Each impact has a series of consequences for us that range from just a little bit of northern lights. Well, for Duluth, a G1 storm means about the bottom third of the northern sky and the northern lights. Once you get to G2, which is also associated with something we'll learn in a moment here called KP, it's equal to KP6. G2, you get a whole northern sky, and then on up. It can affect satellite, electronics, radio transmissions, can damage improperly shielded transformers, power transformers. So like Minnesota Power and so on, they're on the alert where there is a massive storm, I think we had in October. All across the world, we've got these things called magnetometers. These devices, one you see on your right, that measures the crazy stuff happening with Earth's magnetic field. All that data comes together at a center in Colorado at NOAA, the Space Weather Prediction Center, and they produce a forecast. And they issue a number, a KP index in that forecast. You saw from the previous slide that each KP number is associated with storm level. So a KP of 3 is below storm level, just active, we say. KP of 5 for our region as a G1 or a minor storm. Again, we'll have aurora. Anytime you see KP 5, very good chance of seeing that at Duluth. 7, 9, and so on. If you go down to the Twin Cities, southern Minnesota, the KP has to be 6 or higher for the oval to expand far enough south for them to see the aurora. So their threshold is considerably higher than ours. Whereas if you are in let's say you're in Manitoba, then you could see a good storm when the KP index is 3 or 2, because you're up closer to the oval. So this is what I recommend for you to use. It's called the Space Weather Live app. It will alert you. It has little alerts because it'll know where you're at, what your latitude is, and so forth. Alert you to the auroras. It has a little diagram you can tap where you can see the extent of the oval that we've been talking about tonight, as forecast, and just a whole lot more information too. It'll alert you to every major solar flare if you want that. Here's the KP index. When you open it up, this is if you see it. So you're like, oh, it's 3 and it's 10 below. Am I going out tonight? No. I know you don't have this app downloaded, but I just wanted to show you this if and when you do. When you do, there's little 3 bars like there are on any app. You tap those 3 bars and then tap settings. And when you go into settings, you have this, manage push alerts. This is what's going to alert you. It will give you a headline and a sound, I believe, on your phone when there is potential for a good aurora here in Duluth. So you want to manage those things. And for me, I said it, I a little bit of like, I set mine for KP4, a little bit lower, because you never know. But you may want to start with KP5. So when you manage those little alerts, you have a choice to go 3, 4, 5, 6, 7, whatever. Does that make sense? And how to use it? So, and I'm sure you could find instructions as well online. There are other places where you can get information. My website, or not a website, but just my Facebook, is always posting aurora alerts there. And and I'm out in the field, signal, I'll put a picture of those. Put a picture of as well. This is another great place. Has anyone ever visited this website? Great Lakes Aurora Hunters? You have? These people are equal to or crazier than I am. And they are out all over the Great Lakes area, region basically, and they're taking pictures of their camera backs. You know, they are stalwart soldiers of the Northern Lights. And they will post here. So if I think there might be an aurora, but it's cloudy and blue, I'll go here and go, oh yeah, there is an aurora tonight. So, and finally, I just want to wrap up with a few words about photography. Who's taking photos with their cell phone? Yes, well, we can just skip this section, right? This is, somebody just pulled this up at a book signing and said, yeah, people are always doing this, you know, they just do this. And I'm like, good God, why do I spend $6,000 on this stuff with your cell phone? But it really was, there were so many lovely photos that people could take. And you can hand hold these pictures if you have an iPhone. I've got it for the iPhone. But your newer model, like 11 on up on your iPhones, it has a built-in night mode and stabilization. So when you point it at the sky, it will automatically give you a 3-second time exposure. And you just tap the screen so the stars are focused, and then just hold it steady. You don't have to be a statue either. It's forgiving. You'll see 2 crosses. If you can keep those 2 crosses overlapped, they'll disappear. And then you nail it really sharp. So this works. Also, I found there's a little, right at the top here, it doesn't show in that image, there's a little triangle. If you want to go to a longer exposure, you tap that, then it opens up a little scale at the bottom, and you can go up to 10 seconds handheld. You don't need more than 10 seconds for the aurora. A good aurora, 3 seconds works. This is a 3-second exposure of that May aurora. Isn't that gorgeous? And just an iPhone, no problem. If you don't want to handhold it, put it on a tripod. $25, you can get it flat. Put it on a tripod. It has jaws that open up, slide your phone in there. That thing is rock solid. You don't have to worry about anything getting blurred. And the phone is smart. It will give, it knows it's stable now. Find stable position, so it gives you 30 seconds. So you can photograph constellations in the movie. Yeah, it's really affordable. And just to wrap up, you know, I love snowflakes. What's fun about being interested in photography of any sort is that everything is fascinating in nature. And so I try to get in there really close. It's just the opposite of the Northern Lights. I get really close to try to get one in focus. But my point here with the snowflake is to show how this single flake magnified over and over, multiplied, I should say, over and over and over, billions of times, creates these beautiful snowy landscapes and other things that we just open our door to and marvel at. It all starts with something very, very small. And you know where I'm going. Oh, I love you, electron. The tiniest thing touches. Just like the biggest things, you know, like if you're out looking at the Milky Way on a summer night, you're like, oh my God, I feel so small. Well, on the other, these very tiny things put together in nature, create these vast vistas, northern lights that touch us equally. It all comes down to such minutia. And I love that about nature. It's super simple. It's the most complex thing that we are fortunate enough to admire, connect to, and find beautiful. The more beauty you find in your life, the happier you will be. So here's this is from another Morris that just stacks the images together. Man, yeah.
Is that real time?
I tried to get it close to real time, but I couldn't quite make it. I tried like 5 times. I just went with this.
Wow.
But yeah, it was rapidly changing. For those who've seen a corona display, it does move rapidly.
Mm.
And then if you'd like, this is my final slide, if you'd like to take a photograph of this, just so you have these links. You know, you can refer to them. I've got the oval. Noah has a wonderful page that shows the oval continually updates. And do take the oval with a grain of salt, just because you see it over to Duluth, you may or may not be sure to see much aurora. Space Weather Live app, Facebook stuff. Here's a monthly sky map and calendar. That's nice if you want to stay in touch with events. And then this is just a stargazing app for identifying planets and constellations. Do you guys have any questions? Yes.
You talked a lot about the oval, but I'm still not clear. Can you say a little more about that?
It's a place, the oval is the northern lights. It's where all the action is happening. Where all the stuff that's coming down from way bubble that's coming in from the sun, and then the sun material is coupled with the earth, and it's streaming in at very high speed, and it's striking the atoms in the atmosphere within that oval. And it's glowing. It's glowing all the different colors. The photographs don't show it in color, so it's sort of a little harder to imagine, but all the pinks and reds and blues and everything are in there. Does that help? And there's no storm, that oval is really small, and it's just sitting out there in the Hudson Bay. So if you drove up, you can see those colors. Well, that storm, aurora, it expands, and you see all those forms right here. Does that help you? I'm glad you understood. And what, that's a key point.
Do they see the northern lights from the space station?
Yeah, oh, yes, I could have thrown in those pictures. And the thing is, they are up in the space station. So just do this, just go to YouTube and type in space station aurora, and you'll be treated, you'll go on a trip. They point the cameras through the windows, looking down, so you can see all of the lights of the cities. You're plus. And you see it from the bottom up. So those red rays, you can see the full space. Yeah, it's very cool. Any other questions? Yes, sir.
What a good location be to go over your park.
That's a great question. So glad you asked. There are a number of them. You can go to Brighton Beach now as a spot. Go to the far end, to the east end of Brighton Beach and park there. So that you have I checked this out, you have a more open sky to the north. It's still somewhat blocked, but not bad. So that's one spot. Another place is Hawk Ridge, which is probably blocked now, I would assume, or not plowed anyway. But anywhere along East Skyline, but in particular, right where they do the count, where the platform is, that is the most open with a great view to the north. Another place is the dog park on Riley Road, which is by the city sand and salt facility near the soccer fields. You can go there. And then a favorite, if you really want dark sky, go all the way up to the Boulder Lake boat ramp.
Oh.
It's a bit of a drive, but man, it's dark up there. And another place I found was if you go up, like you're headed on County 4 to Island Lake, right? And just before you get to Island Lake, there's a road called Abbott Road. And there's a boat landing sign.
Oh, we've been.
So turn left off
Yeah.
County 4. Have you been there? It's a
Yeah,
a parking lot big enough for 200 people.
yeah.
And it has got a pretty good view. Did you guys see the lights?
Yeah, we also went out to Duluth to Normanna. Was
Oh.
it? Yeah.
That's,
And
yeah, that's the hardcores. Yeah, people don't even care. They just park on the side of the road.
Yeah.
And it's just,
With the
wow.
sheriff.
Yeah, right, and it's just line the road, they don't care. I park there too, and that's some wonderful people. Yeah, that's another, I was gonna say, gee, Duluth and Normanna, there is a light there, unfortunately.
Yeah.
Yeah.
But you can kind of pull farther away from the light. So yeah, there's a number of places. You can look at a Google Earth or Google map yourself too and identify places and then visit them in the daytime. And the key being north of Duluth, so we get the light pollution out. We're lucky in that north of the loop, there isn't much light pollution. Whereas if you went south, you got to look at the over Superior and Duluth, very difficult. So yes, north of Duluth and just out in the country, it's pretty accessible still for us. Anything else? Yeah,
It seems like when there's an intense, they're visible for multiple consecutive nights.
yes, sometimes it just keeps on, the bell keeps ringing, it just goes and goes. That happened on May 9th. Those pictures are from the night of the 9th, went all the way through the morning of the 10th. That night was when that huge green curtain. And so it was 2 nights, and I believe I saw it on the 11th, so I've seen auroras I think at least 4 nights in a row, one time. Yeah, because sometimes it takes the earth a while, it's almost like to empty itself, to come back to a stable place again after all of that disruption to our magnetic cocoon. It's like jiggling and vibrating and doing all kinds of stuff. Yes.
It's getting kind of easy, but if you're saying oxygen gives off red and green, it has to be different energy levels coming out because the light waves are different. So why is it that the red sitting on top of the green one?
Yes.
Just because the green has a faster, smaller wave and the red wave is longer, that it's hanging out there longer and it's slower?
It's because when you're at a very high altitude, there aren't many oxygen atoms. So when they get zinged, it takes like a minute and a half before they lose that energy. That is enough time for them to give off the red light. Farther down in the atmosphere with a lot more oxygen, those atoms are getting pinged by other atoms or molecules so quickly that there's no time for them to release red light. They only can release green in a short interval.
I don't even have an answer.
Does that make sense? Yeah, it's because of how rare it allows oxygen it gives it the time it needs to emit red, which is impossible at lower altitudes when it's being kicked around. Yeah, it has no time. And then the bottom of the aurora is where electrons are trying to get down there. The very bottom is where there's so many atoms and molecules that no light is good. It finally hits a point where they're all excited. They get excited, maybe, but then they give off, it's just vibrational. So you get a bottom. Yep.
The negative part of aurora, like orange because of Jews, any impact?
There has been, not recently, because people are aware of the issue, and so they've protected transformers. I know we don't have enough transformers. We have a massive event. We haven't had a massive event since 1859. If we had this giant storm like we had back then, it would probably take out a number of transformers. And I've read that there aren't a lot of replacements. So there would be a long time for some people without power. Our grid they're well protected. I have not heard any outages here. But there was a massive one in 1889. That province, have you heard of that one? And that was for poorly protected transformers, and millions of people lost power for a day or two. Directly because of that storm.
Does it affect our streaming? Like when because I notice sometimes during these times our reception seems a little iffy.
I wonder, I don't know if it does. I mean, that comes from satellites, right? Ultimately, the streaming. So it can affect satellite electronics transmissions. I know there's a wonderful story that just came out about farmers in the northern parts. Anybody catch that? They discovered that during the October 10th huge storm that we got, it affected they run GPS all the time. So they make straight rows, exactly spaced, and return to the exact same spot. So they're using satellites. It affected the GPS satellites. This big storm on the 10th. And so farmers noticed that instead of going in a straight line, their plows were doing kind of a gentle. There's a great, look it up, there's a great picture of the field with kind of a curly type. And in some cases, the farmer said, I just stopped the track. It was so off, we could no longer, whatever they were doing, plowing, disking or whatever, playing, harvesting. But, yes, it does. I have read that we as humans are too small to be bothered by this. Is it be affected? Maybe someday we'll find out. But it generally affects large things like long power lines and satellites and such, rather than people. The effect on us is what? Holy heck! Perhaps we're affected more than anything, right? Certainly on an emotional level. Yes. Oh, man, I know that's a whole, I have a whole chapter on sound. Has anyone here heard sound? You heard some, would you like to describe, what is your? Right, could you describe it? From the northern lights. Shit, you knew. Some other name go up, too. Just do.
One years ago, we got issue, but almost like a. Oh, that's,
Very low. What's it with the northern light?
yeah.
Did it move according to the, oh, storm? Yeah.
In the morning.
There's been a lot. It's just, and there is a way for the aurora to produce sound, not directly. But there's a scientist I spoke to who's done these sound experiments. He's put microphones, some guy in Finland put microphones on ice, determine the altitude of the sound, the whole thing. And it has to do with how the aurora and the atmosphere can work together to create sound. It's actually not the aurora, but it's the whole magnetic storming. And he has recordings, and I pleaded with him. I said, his name is Unto. I said, Unto, if you could just put those up on a website. He says, I'm not ready. But you can look it up online. You can just type in Aurora Sound Finland. I'm sure it will get you there. He's got one recording. I've got a separate presentation on Aurora Sound, and I've got like 4 recordings from. He did give me some extras, so I'm grateful. But yeah, it's been reported for a long time. And a lot of people, you'll have 2 people. One will not hear a thing. The other person will swear they're hearing the northern lights. Do you guys know Larry Weber?
Yeah.
Larry Weber?
Yeah.
He and his wife, they heard northern lights way up in Canada years ago. Multiple nights. They heard that sort of, as you said, Julie.
How old was he then?
Oh, hasn't it always been kind of the same age? Just stays at that one level. Like eternally curious. Yeah, it's such a. I don't know. I can't remember this. But yes, some have. I have strained to listen and I've yet to hear the voice. So I keep, but the problem is now that I'm. It's really been, I'm starting to lose it in this year. So that time may be gone. Unless I get a special ticket. Anything else?
So I haven't been able to quite wrap my head around, you were talking about the magnetic bubble, and it sounds like the electrons come past here,
Yes.
and then they're coming back.
No, they just, blow right on by. They, you know, it's almost like a swarm of bees. You can picture them. They're headed through the earth.
Right.
And most of the time they will just blow on by because the magnetic field of our planet deflects them away. You know, it pushes them off because but under the right conditions, when the magnetic field from the sun is pointed in the right direction, it will couple with the Earth's field. And then the bees are let in. They are directed back behind the planet along those. They connect back there to the south. They slingshot material in forward. But the sun keeps blowing. Every day there's a solar wind pouring out particles all across the solar system. And these things just, some of them are bigger, some are smaller, but they're constant wind. Even that constant wind bubble and give us. But when you get a big blast. Does that answer your question? But it does continue on. Speaking of which, when that thing, you didn't see it in the video, it's just like that, a slingshot. It shoots out the other side, down that long tail of yours field into space. So when you get a connection there, you also get a bubble shot directly away. So there's all kinds of things. It's really complex. I still struggle to truly understand it. They're working on it all the time, people, physicists. They're very careful to see what they know and do.
Anyone ever felt anything? Physically felt anything? Observing Northern Light.
Like tingling? Like something,
Very, but very, very delicate. I was alone, lying flat on the picnic table, Johnson Lake near, well, northwest of Crane Lake, between Crane Lake and the National Falls. Nothing around. And the other time was on the north side of Paul Lake, north of.
skies.
Well, a couple times there was other people, but very quiet. And just sensing something, energy or, and I don't know what. And it could be all emotional, who knows? Sensitive, something was magnificent and.
Yeah. Yeah, that is definitely part of the aurora experience. And there's a lot of levels. Whether there's like somebody could bring a measuring device out and say, yes, I'm measuring energy going into your body or something. I don't think that's been, there's no science on it or anything about that. But certainly the light, you've got all that atmosphere between you and the northern lights. And so the electrons, all those little particles, they're not actually coming down and hitting you, thank goodness. But that's not to say that their effects aren't touching you in other ways. They do heat the atmosphere a little bit. We don't know. I think there's just, we're in the infant stages of understanding. So, hold on to that. I like that little buzz that you get.
So I think on that note,
Okay.
we'll wrap up here. Thank you, Bob. That was- And then a box, books with you in the back. So if you're interested in buying, you're around.
I'll hang around. Yeah, thank you for mentioning. And then if you really are crazy, I brought a telescope with me. So when I'm done there, if anybody wants to take a quick, it's a very fast setup telescope. If anybody wants to take a quick look at the moon, Jupiter, I'll set up right in the parking lot behind my car. And it's at the end of the sidewalk right there. So for whoever stays. So I know that.
Thank you.
Thank you.